Okay, this is a graph question. We haven't done graphs in a while. It says determine the impulse in 10 seconds. Now remember, impulse is another word for change in momentum. So what I'm trying to solve for is delta P, which I can get by saying F times T. Now you should remember by now that whenever you're trying to do F times T, when you're multiplying two things on a graph together, we're finding the area. So basically what I'm trying to do is I'm trying to find the area under this graph during the first 10 seconds. Now, I actually divided this graph up for you so it's easier for you to be able to figure out, number one, that you should be finding the area, number two, how to do it. So what I do is I have a triangle right here to begin with. To find the area of a triangle, remember triangle is 1/2 base times height. So what I have is 1/2 the base would be 2, so 1/2 of that is 1. 1 times 10 would be 10. Okay, I have to do the same thing here. I've got a triangle. 1/2 of 1 is half. Okay, and then a lot of people want to say that the height is 20. It's not. Remember, the triangle is drawn is 10. So this actually has an area of 5. And people will make that mistake because they'll say it looks exactly like that triangle. Remember, you have to look at the scales. Okay, you also have a triangle here that has a base of 3, and this one does have a height of 20. So 1/2 of 3 times 20 gives you an area of 30. Now I can look at the rectangles and squares. Rectangles and squares are just base times height. So 2 times 10 is 20. 1 times 10 is 10. And 2 times 20 is 40. So now, in order to find the overall impulse, I just have to add these terms together. So 20 plus 10 plus 10 plus 40 plus 30 gives us a value of 110 plus that 5. You get 115 Newton meters.